On the remainder of this page of notes, we've looked at how to develop our parent graphs, and down here on the bottom we want to look at the basic steps for graphing tangent functions. So when I'm working on these, I like to draw a basic curve first and then add in my key values later. It is important that we always watch for reflections and shifts. Now, we haven't looked into shifts yet, horizontal shifts, so we're going to be looking at those here on these graphs. So the first thing that I like to do is I actually still divide mine up into 4 pieces, like I did for sine and cosine, even though I know that's going to represent 2 periods. I like to automatically draw in my vertical asymptotes. I know that every other point is going to create a vertical asymptote. So I like to get that basic in there. I can right now actually mark how high and how low mine are supposed to go, my amplitude. So I can grab that right away and on this graph label this as a 2 and a -2. You may or may want to kind of indicate that on your other asymptotes to help you kind of see how high and low that would go. We can remember that that's going to always be halfway between our key values here. This graph is going to be reflected because of that -2. So I'm going to go halfway and I'm going to go up. I'm going to go halfway and I'm going to go down. Halfway and go up. Halfway and go down. So I can go ahead and I can remember draw in this little piece and then extend it up. So I at least have a picture in my head as to what my final answer is supposed to look like. I don't know how my values are going to change on this yet from my original graph, but this at least gets the basic shape on there. Now, I need to know what are the values for each of these key points. Now, when we try to figure out what this first graph is, what we have to remember is that on our parent graph, the first value that we found to the left of the y-axis was -π/2. We want to look at this entire expression here and how did this change from our basic x. So we're going to compare this to the parent, which would have been -π/2. So when we say find the start, that means that first point. So I'm going to say -π/2 is what we need to set this equation equal to. So I'm going to write 1/3 x minus π/6 equals -π/2. Now, I've got some algebra I need to do. I prefer to get rid of my fractions. So I'm going to multiply everything through by 6. And I'm going to get a 2x minus a pi equals a -3π. Continuing my solving, I have 2x, I have a -2π, which means x is simply -π. So my first value that I need to put on my graph is -π. This gives me that first point to the left, although it doesn't always have to be to the left. The next thing that I need to do is figure out how long did it take for it to complete its cycle. So I need to calculate my period. Notice that on tangent the period is only pi long. So I'm going to take pi and still divide it by the coefficient of whatever is on the x here. So I can write pi over a -1/3, but I know that that doesn't look very good to us. So we can just rewrite that as pi times 3 by multiplying by the reciprocal. So my period is 3π. Now these problems are this particular example turns out kind of nice, but we'll pretend that we don't know what this value is quite yet. Notice that when I look at a single period, my graph, I've only divided it into 2 pieces. So this time I'm going to take my period and divide it into 2 pieces. So my 3π/2. So now, similar to what we did for sine and cosine, our start value, that's not 0, our start value is negative pi. And we need to add to that this distance between each of our points. So we're going to add to that 3 pi over 2. Now we don't have common denominators, so I can visualize this as over 2. But of course, if I multiply the denominator by 2, I have to multiply the top by 2. So negative 2 pi over 2 plus my 3 pi over 2 lands me at a pi over 2 for my next point. Of course, I can put that up here on my graph if I would like. I can put my pi over 2 right here. I can add my 3 pi over 2 again, and I'm going to get 4 pi over 2. Of course, for my graph, I want to reduce that and write that as a 2 pi. That now makes sense because it took 3 pi to complete that one cycle. Keep going. My next point is going to be 7 pi over 2. I can put that on my graph. And one more time, I get 10 pi over 2, which of course on my graph I will reduce to 5 pi. And once again, this one cycle is 3 pi. So it's always important to check that to make sure that your graph actually has the proper length for each period. So that's all that we need to do for graphing our tangent curve, and on the next page we can look at just 2 examples, one for our reciprocal function of secant or cosecant, and then also another tangent example.